So I'll be moderating. Starting off this morning's session, we have a talk called Data-Driven Data Service Development, a research method for informed growth with a dynamic campus environment. So take it away.
Hi, good morning. I am Kelly Burns, and I am the Research Data Management Specialist with Purdue University Libraries. We're going to talk about a project we've been working on for our data services and our institutional repository. And I'm going to be speaking with Reid Boehm, and I will let her introduce herself.
Hi, everyone. I'm Reid, and I'm the Research Data Systems Manager at Purdue University.
All righty, let's see. Okay, so today we are going to talk about our thesis here, why we decided to start this project, some things we wanted to look into, and then we had these three specific goals that we set to kind of help us inform this thesis. We wanted to look into campus researchers, their characteristics, data management plans in particular, their data practices and needs, especially with federally funded grant awards. We wanted to provide insight into the future of our institutional data repository, as well as identify specific service areas that we might need to pay attention to for more support with our researchers. Some items that we're going to discuss today. Let's see, sorry. We are going to give a little background information on the campus research environment, some more information on Purdue University, as well as our institutional repository. And then Reid's going to outline our study design and some of the methods that we took to analyze the information that we collected. And then moving on to how we engaged with the data, what we learned from everything that we discovered. And then I'm going to finish out by discussing how we're using this information to kind of inform our services as well as our repository system, and then how you can use the same methods to do a similar project. So Purdue University is a public land-grant institution in West Lafayette, Indiana, and we were founded in 1896. We're renowned for our engineering and agricultural programs, with a focus on federally funded research and industry. We've got 13 colleges and departments, and for fiscal year 2024, we had 1,179 federally funded grants. Our institutional data repository is known as PUR, the Purdue University Research Repository. It's been around for, we've been working on this for 12 years. It exists as a system and a service. The system includes data management support, collaboration and storage, as well as data sharing, archiving, and preservation support. We also provide consultations for researchers, trainings, workshops, and then we have abundance of resources to share with them. And we also do, we have DMP support and review services. So some anticipated changes that we have that we kind of use to help inform this project. We are looking to pay more attention to data management plans and sharing options, as they're, especially with federally funded grants, as new policies come into practice, and making sure that researchers know about these changes. And with that, there comes a greater interest in the use of repositories that support these guidelines. We're also seeing a lot more larger scale and complex data, and as well as trends in changing data security. So, and then all of that together will help us develop our infrastructure as a repository. Oh, we went backwards. And now Reid's going to talk about our study design.
All right, thank you, Kelly. So to give you an understanding of our sample and what we had, we mentioned the data management plans, and we're very fortunate to have all of the data management plans for awarded federal grants from the years 2020 to 2023. So as you can imagine, this is a large body of data management plans. And I should specify, these are folks that are using the repository as part of their research process or sharing process. So we have this large body of text, and we really needed to break it down further, as you might imagine. So we had, we took the agencies that were most well represented. So that would be the NSF, the NIH, and the USDA. And really, we needed to go down even further. So we looked at the different units based on the federal agency. So for example, with the NSF, we might have biochem or something like that. So from there, we had about 80 that we were using. And we thought, you know, content analysis, because of the way it really does this systematic analysis of our text-based content, that we're really able to get a clear understanding of how this, within the understanding of our campus environment, our research environment, how we can understand the different elements and answer our research questions. And I would say that this is really nice because it's conducive to doing mixed methods. It's, you know, you can get both a quantitative and qualitative understanding. And then I think it's a really accessible method for many of us because, you know, surveys and interviews and focus groups are really difficult to find our study. And so these are the different elements of content analysis at a high level. And Kelly, next slide. And now we're looking at our research questions, and these go back to the goals we presented earlier and our main statement that our main purpose. So now what we're doing is looking at the characteristics. So of course, that's the big thing. We're looking at the overarching things that the federal agencies are requiring of researchers. And then our research question 1 will really go into 2, 3, and 4. So basically what we're focusing on right now is research question 1, and we'll go back and then talk about 2, 3, and 4 as we move forward. Oh, next slide, please.
Whoop, too many.
Let's see. So to think about the research process that we're going to take with our content analysis, as you might imagine, we really have to define our scope, which we talked about here, but then also define how we were going to define things. So we looked at the DMP tool because of the guidance and the attention to those different elements based on the requirements for the federal agencies, but also that this is something that we use across the board, standardized for many of us who are working with folks that are doing data management plans. And then we looked at the NSF General, the most recent one of that, because really, I think there are many folks who would consider this to be kind of the original and kind of the leading agency in some of this over time. So then we created our codebook from there with these definitions. And we also needed to kind of clarify, document all of the parts of this process that were more detailed, that we really need to understand, okay, what are the little eccentricities that we need to look out for? And so then we need to do a little pilot study to be able to understand, are we on the same page? And so this was an intercode reliability. And this is something you can do statistically to understand, you know, where you sit in this. So we were in sync. And so we then were able to kind of flesh out a little bit of the different things that we still, you know, recognize a lot of things that we needed to consider as we were going through the data collection process. And that was a large portion of what we were doing over the past several months. And that was something that we did based on our code book. And then we went through the analysis process once we went through all the data management plans. And now we're in the process of synthesizing, and this is giving us a large body of information. So I'll go to the next slide. So now we'll talk about those the engagement part and what we have now that we're looking at the synthesis process. And reflecting back before on some of our research questions and our objectives and goals, you can see that we're really focusing on some of these big questions. So I think what we're really seeing is a lot of different both inconsistencies as well as connections for folks between some of the different aspects of their perspectives. And so next slide, please. And so to give you, I think we're going to talk about 3 of the kind of arising things that are coming up. Particularly, these are incongruencies. And we also found some really surprising things. So one of the things we want to talk about is how researchers define data and how this aligns with both the overarching federal definition of research data and the DMP tool guidance discussion of research data. Our repository policy of what we publish as research data and those materials that come out of that as well. And then there, of course, is the federal agency specific definition. So for example, the USDA has a very large amount of information that they want folks to share, from anything from field notes to raw data and beyond that. So as we look at this, we say, wow, there's a lot of incongruencies in what is cited here in our data management plans versus the different definitions that we have. And this is something that we can take into consideration as we work with researchers going forward. Next slide, please. So here you can see, based on the percentages of coverages for each of these data types, who's really looking at different types of data or materials that are related specifically. And so you can see some of the big things that people are focusing on. And they're things that you might imagine, I think. But then there's also some very interesting things that were actually arising fairly often within the data management plans, including physical samples and how that these would be treated. So this gives you an interesting perspective on what's going on out there. And next slide, please. Other things that we noticed were the treatment and the way that folks were addressing metadata. As you can imagine, there's the coverage of metadata is very different. They used a lot of the boilerplate text that we have available when it was needed, and so, or when it was addressed. And we'll talk a little bit more about that, but also that there was more talk about how folks were creating documentation and what they were using. So then thinking about where folks were sharing, I think it's really important to kind of see things like email, where this is something that it's really not going to be aligned with those fair data practices and discoverability and public access. Next slide, please. So we found something, and what we're calling this is the boilerplate text effect. And it's been really interesting to see, and we realized that our original boilerplate text that we have actually looks at 8 of the 12 DMP tool, elements. And so, ostensibly somebody could, and several times did, just use that boilerplate text as the full data management plan. And so this is something that we're really going to take into consideration as we're working with researchers and how we continue to use the boilerplate. And it just gives you overall an example of how things are a double-edged sword when you're looking at different types of standard text. And I'm going to hand it over now to Kelly to talk about the bringing it into practice.
Thank you. So with all of that information, we hope to take it and kind of help our services and our repository improve and kind of recognize things for the future on, how we can help researchers. I've actually just started this role with Purdue Libraries in February, and I have more of an outreach aspect in my role. So this has been really helpful in kind of helping me understand, what I need to do, who I need to reach out to, and what what I need to learn more about. So we've kind of started developing some training and workshops. Hopefully that will be informed based off of this information, looking into a lot more outreach activities and programs that we can get involved in. And then I think the main thing is informing team goals. And we've been doing a lot of work with strategic planning, and hopefully this information will kind of help further that into deciding what we need to do as a team, and within our individual roles in the repository and in data services, which also is part of preparing for the future and developing the repository, as well as just general data practices and data services and in our changing research environment within the campus, but also externally as well, and with the federal agencies. Ways for you to bring this into practice if you are interested in developing a similar study. Just some thoughts to leave you all with. We believe it was really helpful for us in addressing researcher needs. So if you have any specific goals or objectives within your own repository or just within your own data services, these are some things that we did that could be helpful to get started. In developing your research questions, you should decide, what is it that you're looking for to understand? Why are you even doing this study? And then again, if you have any goals and objectives, or maybe you need to set some goals and objectives to decide, upon the future of your services. The resources and methods used, accessible materials, what you can get hands-on to kind of help you proceed with this study, decide on a scope, what kind of timing, do you have, or can you, get to do the study? And then finally, deciding how your results will inform the future of your work. This could be within, your system, repository, or just data services, or just as a team itself with, your own team goals and services. So finally, what's next for us? As Reid mentioned, we are still doing synthesizing on this. I feel like we've barely scratched the surface on a lot of things, and we're finding new ways that we can integrate this information. A lot of what we've looked at so far has been just agency based, but again, as Reid mentioned, we've separated into disciplines as well. So we're hoping to dig a little deeper into that. And then that we can kind of forecast changes and trends. We would like to use this information to work with other campus partners, for example, research computing. We've got a lot of information on, how people were viewing and using campus storage. So it'd be a really great opportunity for us to work with them. And then just deciding who else needs to be part of this development, whether it's within the libraries or within the research community, or anywhere else on campus or outside of campus. So that is our presentation. If anybody has any questions, feel free to ask. If you have any experiences you want to share, or how you may want to use this information.
Two questions. Looks like there's a couple in the chat. Do you have DMPs for all grant applications from your institution, or only those that are utilizing PER? I would love to have a larger sample of DMPs coming out of my institution, but have found them difficult to acquire.
Do you want to answer?
Yeah, I can speak
Sure.
to that.
Yep.
We've had a relationship with our Office of Research, with our sponsored programs, services, and there's someone who is very generously providing that each month to us. And these are from her specifically. So she goes through and says, okay, these are the per ones that we have. But I think one of the things that we just recently talked with her about is, can we get all of them? And so we're going to do that in a few months. So that'll be even cooler to have that.
I think that essentially answered the next question. But scrolling back, there was a response that about the boilerplate, that this is the precise reason why I've resisted creating any kind of boilerplate text for our research data services despite researcher demands. So maybe you can talk a bit about sort of the pros and cons of having that boilerplate language for just a minute.
Kelly, go ahead. You had a lot of good ideas what we were talking about.
I had so many thoughts when we uncovered this, and I'm still not over it. So, yeah, I think it is, like Reid mentioned, it's kind of a double-edged sword. I think it is helpful. Researchers don't have a lot of time on their hand. They work, 16 hours a day. So sometimes they just need to get the job done. And I understand that. But it's not conducive for, planning, their data management. So we've kind of talked about maybe, because a lot of the inconsistencies were with, our boilerplate mentions such and such and such, but then they also mention, storage elsewhere or, archiving elsewhere. And so it's like, okay, did they use the boilerplate text because they're using per, or are they actually using it somewhere else? So one thing we've talked about is maybe just like splitting it up and having like a use basage, like if you're using per for archive and preservation, use this part. If you're using it for active storage, use this part. Just kind of like giving the option of kind of putting the ball in their court, saying you need to let us know what you're using our services for. And then we'll be able to get a better idea of, maybe what is or isn't being used. And maybe it'll prompt more questions from researchers about what services we do have, or, what any of that even means. So.
Thank you. We're going to move on to our next speaker, who's going to talk to us today about a data accessibility checklist. Take it away, Brandie.
Okay. Hello and good morning. My name is Brandie Pullen. I use they, them pronouns, and I am a resident librarian at Virginia Tech. Today, I'll be talking about the data accessibility checklist that I've been working on. So we have recently renamed the data accessibility checklist to basic data accessibility checks. This renaming was done to reflect that this checklist is not all encompassing. I can't stress that enough. This is just a starting point for how to increase the accessibility of research data. This checklist deals only with digital content and is based on the DCN's accessibility primer. There is always more you can do for accessibility than what will be able to be presented in a checklist. So this is just a starting point. So sections of the checklist, we have all types of data, text, tabular, code, and images, which is further split into maps and data visualizations for more considerations. And sometimes you'll want to take considerations from multiple sections, like there is text in tabular data, so you can see an overlap with that. And I'll just be going through a few concerns of each type of data. There are more suggestions in the actual checklist than what I will get to today. So all types of data considerations, you want to have clear file structure and organization, and give each file a name related to what it is. So no file names like data or file 3. You want to help the user understand what it is that they're opening. For text, you want to remove images of text if possible, and if that's not possible, provide plain text nearby within the document. Formatting such as tables should be necessary and created structurally within the document, not just visually. Don't take a screenshot of a table and throw it into your text document. Actually create the table through the text document itself. And images within text documents should be described with alternative text or within the document near the image. And this is a great link that helps you learn how to create alternative text, because that can be kind of intimidating you when you don't know where to start. So this gives you a starting point. Text continued. Within the whole of the document, embed hyperlinks to unique word phrases. So what does that mean? If you have the phrase Virginia Tech Data Repository hyperlinked in your document, do not hyperlink the same phrase, Virginia Tech Data Repository, elsewhere in the document with a new destination. You can hyperlink it with the same destination, but you just want to make sure that the phrase you use is unique. Do not use solely visual aspects of text documents to convey meaning. So don't use red and green to indicate bad and good respectively without another way to access the information. And text continued even more. This is the longest section of the checklist. You'll want to use one of the recommended fonts for web accessibility. They're listed here for you. And use of the software's built-in tools to check document accessibility. So if you have Microsoft Word document, you go to review and check accessibility. And if you are working in a PDF through Adobe, you click all tools, view more, and prepare for accessibility. Tabular data is data that's in rows and columns. So as a simple and open file format, comma or tab separated value formats are not only best for preservation, but for accessibility as well. Try not to merge cells. We see a lot of merge cells with people trying to make their tabular data more visually appealing, but that can mess up screen readers. And within spreadsheet applications, every cell should hold only one data point. And you should have column and row names that are both clear and meaningful. We'll see a lot of abbreviations or shorthand for things, and it's just better if you write it out completely so people know exactly what you're trying to convey. For code, you will want to document work throughout with comments and include appropriate alt tags in your code for any visualizations. I'll talk more about visualization shortly. And also use camel case when naming and calling files and variables rather than underscores. Also, I see a comment in the chat. There seems to be a lot of overlap between good accessibility practices and good machine readability practices. Yes, that very much so. And one of the considerations for code is actually it should be easy for the machine to read and easy for humans to read. For images, you'll want to provide alt text for images. This is another resource that helps you write alt text. It's just like the other one, just giving you a guideline on how to get started. If color is important to the image, name the color in the description. If possible, provide the underlying data that generated the map, 3D object, or other image. And that's not always possible, and that's understandable. And also have a 3:1 contrast ratio between adjacent colors. This is another source that just talks about contrast and what you're looking for to make your data as accessible as possible. For maps, you'll want to use a map-specific tool to check for color contrast. My favorite is Color Brewer. You can pick whatever you like, and then the hex codes are listed right here for you to pull and use in your own maps. The key should naturally be explained in the overall description of the map and doesn't need a separate section. And if the map's land and water are relevant, then you should describe those labeled areas, including their relationship and distance to each other. Basically, if someone is visually impaired, you'll want to present your information so that they can still receive all of the information that's needed from your map. And data visualizations. So visualizations are ways to present and highlight patterns, trends, and connections using the brain's ability to visually process complexity and take shortcuts not possible when looking at raw numbers. We've seen quite a few data visualizations at SEDLS, and they've all been really great. And some considerations for your data visualizations are to describe the visualization so that users can come to their own conclusions from your description. And the example here is if there's a pie chart available, you'll want to list each section's percentages, not just which section has the highest percentage and what you think that means. Let people come to their own conclusions. So this is a link out to the checklist that I will drop in the chat as soon as I'm done, or I can do it right now. So that takes you directly to the checklist. And it also takes you to the DCN accessibility primer that it was based off of. And as you can see, there is a ton of information in this primer, way more than could fit in a checklist. And I wanted to point out that they have accessibility by data type, where they talk about text, tabular, code, images, but they also talk about time-based data. And unfortunately, that did not make it onto the checklist. And there is one last consideration I wanted to bring up. The Department of Justice is updating their policies to now require more information provided online to be accessible. We don't yet know how this is going to affect data deposited at institutional repositories, but hopefully this checklist can be a good start to making the data more accessible. I'll stop sharing. Should be plenty of time for questions.
Such a great reminder of some of the accessibility things we should be practicing. Appreciate that a lot. I was wondering, how do you talk with researchers who are already overwhelmed with getting data ready to be shared and sort of adding this additional consideration?
Yeah, so at the Virginia Tech Data Repository, we have started to integrate the checklist with our workflow. And depending on how many curation suggestions we already have, we take that into consideration before suggesting even more accessibility concerns. We will bring up, hey, for accessibility specifically, can you make these specific changes? And some of those are met with more pushback than others, like merged cells and tabular data. If someone has spent a long time trying to make their tabular data visually appealing, they don't really want to go back and undo all of that effort. So we find mixed results in trying to ask depositors to make their data more accessible.
feel free to add questions to the chat as you think of them or comments. And I think we'll move on to our last speaker for this session. Oh, here. Reid has one. If you were to recommend one thing for getting started, what would you recommend?
One thing for getting started would be to use the checklist. It's supposed to be really short and the starting point to get you more involved in data accessibility. And then when you have the time actually reading the primer itself, it's full of fantastic information.
Okay. Our third talk today, we're right on time, is called Human Judgment and Data Curation in an Age of Automation. Please go ahead, Aditya.
Thank you. I'd like to thank the organizers for putting this conference together and to everyone in the audience today for attending. My name is Aditya Ranganath. I'm a data librarian at the Center for Research Data and Digital Scholarship at the University of Colorado, Boulder. And the title of my presentation, which is going to be more conceptual than empirical in nature, is Human Judgment and Data Curation in an Age of Automation. So one of my job duties at the University of Colorado is to help curate research data that comes into our institutional repository.
I'm sorry to
and
interrupt, but we're not seeing your slides right now. We're just seeing a loading screen.
I'm not sure why that is. Are you seeing that?
Yes, they're there now. And looking good. Okay, thank you.
Great, thank you for letting me know. And so one of the projects that we're currently working on is to automate some of our data curation workflows. And I've also talked to some data curators and librarian colleagues at other institutions. And they've also mentioned to me that the automation of various research data curation workflows is a priority at their institutions. And given this general trend towards implementing or trying to implement some automated curation workflows, I think it's worthwhile to think more broadly about the relationship between automation and curation. I think doing so raises a lot of interesting questions that deserve to be explored in the coming years. For example, what's the potential of automation in the realm of data curation, and what are the potential drawbacks, costs, or things to be wary of? What are the implications of automating data curation tasks for the broader profession of data curation and its future evolution? How could artificial intelligence shape automated data curation workflows? And what will be the impact of machine learning algorithms on the division of labor between humans and automated systems in the realm of curation? I think these are some of the questions that I've been thinking about, and I don't have answers yet, but I wanted to use this presentation as an opportunity to reflect on some of these questions and maybe provide some framing and context that could guide discussions and point the way to some answers in future research. So my assumption is that most of you in the audience are at least somewhat familiar with the concept of research data curation. But I want to start by briefly providing some relevant background for the benefit of people who might be students or working in other areas of librarianship and might be attending the conference as a way of learning more about data librarianship. So I think the starting point for thinking about research data curation is that the research data that underpins research results and publications and empirical research uh, are that data is increasingly encoded in digital formats. And publishing and sharing research data as an intellectual object in its own right is now viewed as an important part of the modern research enterprise for a variety of reasons. So, for example, data publication facilitates scholarly transparency, research reproducibility, and data reusability. And in addition, data publication is increasingly a requirement among funders, including the federal government through its various funding agencies. Despite that widely recognized importance of publishing research data, it's important to recognize that research data sets or collections are very rarely, if ever, automatically ready for publication and dissemination at the conclusion of a research project. They often require certain interventions before they're ready to share with the world. And these interventions essentially constitute data curation, which is the process of managing and preparing research data and related materials for publication, long-term preservation, and reuse. So in my experience, curation actions are typically taken towards the end of a project's life cycle when project data is submitted by researchers to a research data repository. And in broad terms, the curator's mandate is to make the data compliant with the FAIR principles, which stipulate that published research data ought to be findable, accessible, interoperable, and reusable. And of course, every data set is unique, and curators are typically not subject specialists. So they have the fairly difficult challenge of quickly assessing the data set and identifying ways to make the data set FAIR compliant. Depending on that assessment, curators work with researchers to suggest or implement a range of practical interventions that increase the data set's fairness, for lack of a better word. So for example, they could do anything from cleaning the data so that it avoids inconsistencies or redundancies, to helping create or improve data documentation and metadata, to checking the data for ethical and legal compliance. So as I mentioned earlier, we've recently seen a growing interest in automating certain data curation workflows. And so far, the focus has been on automating discrete tasks using traditional programming techniques that specify very explicit instructions to the computer in the form of if, then, do rules. So in other words, a program executes a given curation task by following a sequence of explicitly formulated rules that are specified by the programmer. So the automation algorithms currently in use or in development can be seen as complementary to the labor of human curators rather than as a substitute for them. The work of human data curators requires a lot of intuition, guesswork, and implicit knowledge that's very difficult to codify in algorithms based on explicit rules. And ultimately, it's the curators that are going to be making choices about which automated curation algorithms to apply and when to apply them based on their evaluation of a data set and their sense of what improvements it needs. There's a very perceptive paper on what exactly data curators do and the sorts of tasks entailed by data curation. And that describes data curation as a craft and data curators as craftspeople that make very nuanced judgments based on contextual knowledge and skill, and who are guided by abstract conceptual representations in their work, exercise creativity, and work collaboratively. We can therefore think of automation algorithms as tools in the hands of these craftspeople, or technologies that complement their work, because the traditional programming techniques that these algorithms are based on can't capture the implicit or tacit knowledge that forms an essential part of the curator's craft. They can't really replace human curators. And so stepping back a little bit, this idea of tacit knowledge is an idea that's been developed by a lot of philosophers. It suggests theoretical and practical limits to automation in a variety of professional realms. And the philosopher who did the most to develop this idea was Michael Polanyi, who famously observed that, quote, "we can know more than we can tell," by which he meant that we understand a lot of things implicitly or intuitively, but can't formalize that knowledge in the form of explicit statements that can be codified in a series of if-then-do rules that constitute traditional computer programs. So in other words, human beings intuitively or tacitly understand things that can't be explicitly codified or formulated. And given that so much of human knowledge, including the type of professional knowledge that's a part of the curator's craft, isn't amenable to that kind of formalization. That implies that humans will be kept in the loop and that they won't be displaced by automation. So Polanyi's paradox points towards a symbiotic or complementary relationship between humans and traditional automated systems in a variety of domains, including data curation. I think that brings us to artificial intelligence. And one reason why artificial intelligence, for all its current limitations, is a potentially revolutionary technology is that it offers a way out of Polanyi's paradox towards a framework in which tacit and intuitive knowledge that can't be formalized is nevertheless embedded in automated systems. So the basic idea here is that in cases where it's impossible to explicitly codify a set of procedures in a traditional algorithm that takes the form of if-then-do instructions, we can instead use a machine learning algorithm that doesn't need explicitly codified rules or instructions. Instead, it can inductively learn from data and fill in the gaps that can't be explicitly programmed. I think David Otter, who's an economist at MIT, put this idea in very concise and clear terms. He says that the simple idea of machine learning is to apply statistics and inductive reasoning to supply best guess answers in cases where formal procedural rules are unknown, where engineers are unable to program a machine to simulate a non-routine task by following a scripted procedure. They may nevertheless be able to program a machine to master the task autonomously by studying successful examples of the task being carried out by others. Thus, through a process of exposure, training, and reinforcement, machine learning algorithms may potentially infer how to accomplish tasks that are proved dauntingly difficult to codify with explicit procedures. As I mentioned before, the current efforts to automate data curation workflows use traditional techniques and view the relationship between the labor of human curators and automation algorithms as complementary. Automation is a tool in the curator's toolkit, not a substitute for the curator. But as the artificial intelligence revolution proceeds, it's inevitable that people will become more ambitious and turn to exploring the potential of artificial intelligence algorithms that circumvent Polanyi's paradox to provide more comprehensive automation of the research data curation process. In a recent article, some data and information scientists pointed towards this more ambitious automated future using an analogy. In their words, this analogy for the future of data curation is the data washing machine concept, where we could put all our data laundry or all our dirty laundry into a washing machine with some soap, set a few dials, and our clothes come out clean. In the same way, we should be able to put all our data sets into a data washing machine with some metadata and curation rules and collect our data error-free and fully integrated. That's, of course, a very ambitious vision for the future of data curation and envisions a level of automation that's considerably greater than what's currently being attempted at research universities, as far as I know. It's a vision that moves away from automation algorithms functioning as complements to human labor and towards algorithms potentially serving as substitutes for human curators. And it's worth emphasizing once again that this vision depends on machine learning algorithms that can circumvent Polanyi's paradox and encompass the intuitive and tacit knowledge that traditional algorithms can't account for. So where does that leave us and where are things headed? I think current automation efforts using more traditional computational techniques will proceed, but it's unclear whether these efforts will eventually be superseded by more ambitious and encompassing automation systems driven by AI. For now, I think there are some things that we can do and some questions that we can ask that would allow us to actively engage with the possibility of an increased role for AI in research data curation. First, I think the potential impact of AI on curation remains quite murky, and it might be worthwhile to investigate this issue empirically, even if it's done in limited ways. It's possible, for example, to provide many of the large language models in use today with a research data set and ask it to provide curatorial recommendations. It's unclear, though, whether those recommendations or insights are useful or comparable to what a human might offer. And so I think systematic research into the efficacy of these tools as curators might help orient us to where things stand and where they might be going. Even though the implicit knowledge of curators may be reflected in today's AI applications. And again, I think that's something that we need to investigate. Um, we don't know if that actually is the case. And so we need empirical studies of AI's strengths and weaknesses in this space. The second thing I would note is that data curation, data management, and data governance are significant topics of interest outside academia as well. And it's likely that efforts to automate these processes are going to be an important priority for the private sector in the coming years. And so I think it's important to keep an eye on those developments and consider their importance and relevance for research data curation of the type that we do. The third thing I would note is that it's important to push back against the concept of the artificial intelligence-driven data washing machine that would displace human curators and take them out of the loop entirely. I think we all know that curation is very rarely a straightforward process and often involves trade-offs without a quote right answer. The washing machine analogy doesn't account for those trade-offs, which typically have to be discussed in conversations between the curator and the researcher. So the basic point is that curation is a very deliberative process, and algorithms, even algorithms that are capable of learning, might not be equipped to engage in deliberative processes in the way that humans are. And so that suggests that even if the data washing machine were technically feasible, it might not be desirable to the extent that it cuts off deliberation that's essential to the curation process. And last, I think it'll be important to develop community standards and norms within the community of professional data curators about how AI is used in our work. As the AI revolution gathers pace, I think it's going to be important for the profession to advocate for itself forcefully and advocate for its expertise forcefully, and to assert its right to direct the course of AI adoption based on its judicious assessment of various trade-offs and risks. So as you could probably tell, my thinking about these issues is definitely still in its very early stages. Ultimately, I think the goal is to use automation, including automation driven by artificial intelligence, potentially, to improve the quality of published data, while simultaneously respecting the expertise and advancing the professional standing of data curators. And I think that goal can only be advanced through a lot of collective discussion and deliberation about the relationship between AI and research data curation. So I'm grateful for the opportunity to have shared some of these ideas with all of you. I'd be happy to try and answer any questions you might have right now or over email. I put my email on that slide if you're interested in getting in touch. And thank you.
Thank you. We do have one question so far in the chat. A bit long, but very interesting and important. I'll just read the end of it where the question lies. How do you see the discussion going when it comes to setting the bar for good enough data curation? And will this be influenced by the scale of curation demand?
Yeah, I think that's a great point. I do see that trade-off, and I think part of the movement towards trying to automate things, maybe not necessarily using AI, but using some traditional programming techniques, comes from the fact that there is growing demand for the services that we provide, especially with all of these publisher requirements and requirements that researchers are facing. All of a sudden, the demand for institutional repositories is increasing. And the burden on curators is increasing. And so automation is potentially a way to alleviate that burden. So I think there is a potential trade-off. I also think that there is the potential, you know, to identify some sort of division of labor between automated systems and humans. And I think to the extent that we can identify things that machines are really good at, and delegate those tasks to them, it potentially frees up a lot of time for humans to focus on the things that they might be better equipped to handle, things that require a lot of nuanced judgment. So I think there is the possibility that incorporating these systems into curation workflows um, might not necessarily diminish quality, but by combining the labor of human beings and automated systems, the quality of the end product might improve, and the ability to scale might improve at the same time. It's an interesting question, and it's definitely something I'll have to think about more.
For one more question, this one's on sensitive data. How do you think AI can be incorporated into curation where sensitive data are frequently encountered and in need of curation, but the sensitivity isn't necessarily known prior to curation? When many of these models reserve the right to train their models on anything that's input into them, i.e. could ingest sensitive.
Yeah, well, I think it's that sort of question that points to the need for s- you human curators that are equipped to handle that are equipped to handle sensitive data in an appropriate way. Um, or I think that speaks to the need, even if these artificial intelligence systems become more sophisticated, and more powerful, for why we might need humans to continue to engage with this kind of work. Um, yeah, and running models, there might be technical solutions to that as well, but there are also probably um, ethical dilemmas or questions that a human might be better equipped to judge.
Yeah, well, that takes us to the end of this first session this morning. We're going to have a 15-minute break and come back here for another session. So it'll be again in this room, so you can stick around or come back at 15:15. Thank you. Let's give a round of applause to all of our speakers so far, and see you back in. Fantastic. Okay, welcome everyone to the final general admission session for the conference. There'll still be one more workshop after this, but this is going to round out the main programming. We've got two talks this session, both about thinking about graduate students. So first up, we've got rigor and reproducibility for health sciences graduate students. Go ahead, Nina.
Thank you. Appreciate having folks here for my rather niche talk, but I hope that this will give you some ideas. Although I apply it to graduate students, I think it could actually be applied for undergraduates at some campuses as well. I'm Nina Exner. I'm the data librarian, the one data librarian, but a whole data librarian, which is more than a lot of campuses have. At Virginia Commonwealth University libraries, I support our health sciences library and our generalist academic library. If you've heard me talk, it's probably about like policy or education or something like that. Those are the things I focus on. I don't do curation. I'm amazed by people who can do that because, as we just heard, it takes a lot of really brilliant knowledge to do. Most of my work is with graduate students and faculty. VCU is a large R1 by the old rules and the new forthcoming rules about what an R1 is/will be. In an urban setting in Richmond, Virginia, we have a pretty big annual research enterprise for a non-flagship, and our health sciences library supports a school of medicine, as well as a school of dentistry, nursing, pharmacy, and a lot of health professions, including physical therapy and occupational therapy. And we also have an academic medical center, or hospital. And what I'm talking about is R&R, rigor and reproducibility, and transparency, and some other kind of vague open sciencey stuff. There's a specific NIH-driven phrase of rigor and reproducibility, so I'm going to be giving you some information about that. But I'm also going to be talking about how we've applied those rigor and reproducibility requirements for School of Medicine and Biomedical Sciences course on rigor, reproducibility, and transparency in research. So the whole class is focused on rigor, reproducibility, and transparency. It is a 1-credit summer class. It's required for our MD PhD trainees. And these MD PhDs, this is a dual track program with the super high performing people who are going to get a research PhD and a clinical MD. They have to take this 1-credit class, but it's open to any graduate students with a particular emphasis on trainee programs. And we have cardiac sciences trainees that are definitely going to join as a requirement next year, and I'm not sure what other trainees might come on. And I'm going to talk about what a trainee is some in a minute. I was specifically invited to be on the instructional design team, so woo. The lead instructional design team person was the associate dean of research for our School of Medicine. So of course I said, yes, I will definitely be there. Thank you for inviting me. So when I say required of our MD PhD trainees, you probably were like, okay, you told me what MD PhD was, but what's a trainee? So I'm gonna take a big loop away from what the class is and talk about the NIH, because if you see me talk, it's probably going to have the NIH or some other federal agency involved. The NIH is this big funder of academic research in the US. They basically are the most money contributing people for any kind of medical or medical adjacent types of topics. So just for those of you that have not had to deal with the NIH or have heard someone talk about the NIH but not been sure why it matters, they cover nursing and aging and mental health and bioengineering and environmental health and medicine and cancer and pre-medical bench science and just tons and tons of academic research in the US. And in addition to these research grants, they also fund training and education in the medical and medical adjacent types of topics. You may see these referred to as T grants or TF and K grants if you're talking to a wonk like me who is entirely involved in funding environments and federal funders, but they're more officially called training grants. That's grants to train people. Training grants come in two different flavors. One is grants to individuals, which is more like what you probably traditionally think of for grants and scholarships, which are like, I'm going to do some fancy research as part of my graduate experience or as part of a postdoc, and I want money to do that with. That's the individual training grant programs. But there are also institutional training grant programs, which are grants of money to the campus to train some people. The most common of those is the institutional training grants or T awards, if you're talking to your Office of Research. Also, do remember that T award. I'm not saying that just for my amusement. I'll explain why you might care in a minute. What makes it institutional instead of individual is it goes to the university, then the university runs the program, including paying administrators to oversee it, setting up lab placements, holding a bunch of extracurricular workshops, all kinds of tracking on outcomes, recruiting and paying the students for tuition fees, stipend, housing. If you have a lot of research assistants, graduate research assistants around, there's a good chance that your campus has an institutional training grant if you deal with any kind of health and biosciences at all. Some codes that you might hear about, there is actually an undergraduate level program. I used to work with these folks a long time ago when I focused more on undergrads. I don't these days, but if you have a MARC program or a U-STAR program on your campus, you probably have an institutional training grant. There are also pre-doctoral for PhDs and MDs and postdoctoral as well. And I see that my time is almost up. Ooh.
No, you're good. You've got 7 minutes.
I got 7 more. Oh, thank goodness. I just lost track of time. Or anyway, we care about the grant because this grant type, these institutional training grants for the last few years have been required to describe a plan for instruction. Oh, and thank you, Marla, for reassuring me. Have been required to describe a plan for instruction in research methods to enhance rigor and reproducibility, and how they will train in rigorous research design, including relevant data science and quantitative approaches. These topics that have to go into these institutional training grants became scorable or part of the grade for whether the campus gets the grant or not a few years ago. So this isn't fresh news, but grants run slow. If you want to know more about rigor and reproducibility, which includes things that you would think have to do with reproducibility and things that you probably don't, and that aren't very library-ish, there's some links in my slides, which will of course go on the OSF at the end of this. The infographics are really helpful. And if you head to those, more of the guidance is on rigor than reproducibility, and they're really focused on research grant writers rather than the training grant content. This requirement for instruction and methods for enhancing reproducibility was really new, and there were no examples at all when the requirement came out in 2020. And that, to loop all the way back from the why you might be able to apply this on your campus to what we did on our campus, is where we found ourselves when we had to renew our big MD PhD, well, big dollar MD PhD training grant. Since there were no existing like success cases or specific information pieces, we had to make it up. What we did know though was that because it's scorable, the peer review scientists would be peer reviewing it and giving it a grade, or as part of the bigger grade for whether we got the grant. So we need to apply our thoughts about what scientists would care about in this process. So our team included the aforementioned ADR of School of Medicine. Yes, I will definitely do what you say. Our biostats department chair, our data science lab, the research integrity officer or person who does ethics training at our/your campus, and the research data librarian. I am also part of the data science lab, so I guess I got called in twice. I can't clone myself yet, though. We did a lot of brainstorming and discussion and searching for topics. The places that I looked at, other than networking with my professional colleagues, thank you, professional colleagues, were the National Academy's reports to kind of get a feel of what were the, that's the National Academy of Medicine, National Academy of Science, National Academy of Engineering, to look at what were the big topics that were being sort of hotly discussed by science bigwigs. And so those are also resources that I can commend to you if you're looking for ideas. Some of the stuff that rose to the top were statistical issues in Rigor, not my problem. Reporting and dissemination of results ethically and transparently, that is my problem because that's around open science, and I do some of that. Causes of misreplication, technological causes and biological causes. I do the technological, but not the biological. And then robust design and modeling. So I partnered with the open science folks. The subgroup, we paired off for multiple different modules in this. The technological causes of misreplication, i.e. lack of documentation, and ethical and transparent publication. We expanded on those with a lot of subtopics, and I will let you peruse the exact details in the slides if you so choose. The section that I led the discussion of was sort of conceptually intended to get them from the end of their analytical process to the planning process for journal article submission. And that's because someone else wanted to do the versioning and documentation parts of things, and I seeded that content, although I think we could have done really, we certainly could have had a library-ish approach to writing documentation and metadata. But I decided to take this part instead because no one else was willing to take it. We did a journal article discussion board post, sort of traditional, make one pro comment, make one con comment, and then comment on someone else's comments. I had them look at an article that was known to be retracted that I harvested from Retraction Watch, retracted because of the data, and skim the beginning of it and just identify one thing that they could have done better in writing the article that might have helped them avoid retraction. That was intended to be a sort of brainstorming activity. And then find and post whether a journal in their particular discipline was a signatory to the TOP guidelines, which were which had been sort of fallow for the last couple of years, but I just recently saw that there's a new TOP guidelines out there. And now my time really is getting close to done. I covered data and records and security because no one else was willing to cover it, and had them discuss storage in their labs or other rotations. Some of them are in labs, some of them are in field work. I did data management at the end of a study, finalizing their protocol, sharing protocols, personal archiving and documentation of their data for their own future self with an activity based on the tier protocol, although I think any your favorite organization approach could do, and applying a reporting checklist. We evolved basically based on student feedback. We changed some stuff. I took out the checklist we originally used and switched to the Equator network. That's probably my top recommendation. I moved the how does your lab do stuff into a discussion board activity. And this year we had an AI discussion, a sort of open AI discussion. So we've been trying to evolve as we go. If you are interested in finding out whether you have a training grant on your campus, you can do that by searching reporter.nih.gov. And I have the exact details and a screenshot for where you would do that. If you want to see, it's T30, it'll be code here, or where I've got the red circle, we'll go in T32 if your campus does a heavy PhD load, and T34 if your campus is primarily baccalaureate. And I've got a bunch of links for activities that you could consider if you don't already have a set of favorite open science discussion activities. So lots of links in the slides, which I will put up when they put up our links. Bye.
Thank you. Excellent. Questions?
I see in the chat, since grant support was a key driver of the development of this course, am I aware of corollary NSF requirements for programs like the REU and RETs, presumably? No, but NSF did expand their rigor reproducibility, oh no, rigor reproducibility, I'm sorry. Re RCR and E, so responsible and ethical conduct of research. They just had to change it, so my brain has flushed it entirely. Our ECR requirements, and those have some transparency topics. So while that's not going to be similar to a training program, it might be a good area to reach out to your RCR/RECR, your ethics trainer for campus, and see if they want a hand with that. That's actually true for NIH-focused campuses too. Because both have sort of evolving stuff going on about transparency in the computational environment, stuff like that. There's been a general big push for that. It's not as good, although campuses with REUs and RETs tend to, which are just a very specific NSF set of programs, research experiences for undergraduates and research experiences for teachers, tend to look for workshops. So there could be some. Also, lots of big changes in research integrity happening right now, and those will usually trickle out from research integrity policies to research integrity training policies. So that could be a good time to reach out to your ethics office anyway.
That's what I was going to ask about, because I think NIH just updated their integrity policy. Are you going to have to revamp your course, or are the changes not something that will affect this type of course?
I have not done a deep dive of the new issued policies yet. It's been a busy month. So I'd have to check. And but NIH is a little bit weird about how their research integrity stuff moves from there to the ethics part of their training requirements, the RCR/RECR, and the trainee programs that go mostly through the almost a separate process for creating their guidance. So yes, it will probably affect things, but I actually think discussing AI and transparency in the evolving AI situation is going to be a faster and more pressing issue, even though it's not policy driven. At a guess.
Yeah, no, I think that's a good point. Okay, well, thank you so much. We are going to move on to our next talk, which is called Flipping the Data Lifecycle, Teaching the Why of Data Management to Graduates.
Thank you. Hello,
Isaac.
everyone. My name is Isaac Wink. I'm the Research Data Librarian at the University of Kentucky. And I think the talk I'll be giving will actually be a pretty good pair to the one that Nina just gave. So thank you to the presenters for that. My talk is titled Flipping the Data Lifecycle, Teaching the Why of Data Management to Graduate Students. This presentation grew out of work in my role giving data management best practices sessions and instruction to graduate students as I work to establish data management education at my institution. For this presentation, I'll be describing a lesson plan I developed that seeks to leverage actual shared data sets in the data repository ecosystem to foreground data management best practices, thus demonstrating their importance to students. Now, I'm sure that this group is no stranger to the importance of data management education, as well as the barriers that we encounter in trying to bring that instruction to researchers at all levels, including through classroom instruction. Studies such as the one sampled here consistently show that instructors at the graduate and undergraduate level will frequently identify data management skills as important for their students to learn. While some of these may be discipline-specific topics, there are plenty of general ones as well, including data organization, metadata applications, software workflows, and reproducibility of results. All of these present opportunities for fruitful partnerships with data services librarians. While they acknowledge the importance of data management, however, in practice, many instructors often are not able to fit it into their curriculum. Time is frequently listed as one of the most common reasons for not addressing data management in class, as are beliefs that specific topics are better covered in other courses. I'll note that while this chart comes from a survey of instructors at the undergraduate level, similar results are found in surveys of graduate instructors as well. The challenge for data services librarians seeking to get into the classroom, then, is significant but straightforward. Given time constraints, they need to be able to develop data management instruction that's impactful in a short time frame. The lesson I'll describe is my attempt to address that challenge. In reviewing the instruction sessions I had delivered so far, I noted that I would frequently start at the beginning of the research data lifecycle, depicted here using Data 1's categorizations. Even when I discussed data management practices that would come into play downstream in the lifecycle, such as data documentation and preservation, I didn't think I was necessarily communicating the importance of these practices in a way that would stick with students. So instead, I decided to try turning the data lifecycle on its head, starting towards the end of the process with dataset discovery, rather than with project planning. This would also give me the opportunity to work with students on their dataset discovery skills, a task that can be particularly and increasingly important for graduate students who may need to reuse existing data sets in their coursework when time constraints mean that original data collection is not feasible. The lesson is divided into 4 parts. First, the librarian or other instructor delivering the lesson should identify the data repositories they'll have students work with and introduce students to them. Next, they provide students with guiding questions for evaluating data sets they come across and allow for time for independent exploration. Then, the instructor opens it up to a discussion where students identify on their own a number of common data management issues they've identified in their data sets, providing a lead-in for the final part, in which the instructor provides models of good data management practices. Parts 3 and 4 here are paired. Students identify problems in data management, and the instructor then provides solutions. The choice of repositories to use for this lesson will depend on the discipline of the course and should be chosen in consultation with the lead instructor when possible. I've found that the repositories in the Generalist Repository Ecosystem Initiative, such as Dryad, Zenodo, and Harvard Dataverse to be good options, given that they have easy-to-use search interfaces that may be more intuitive for students and therefore quicker to be picked up on in the space of one lesson. That being said, utilizing domain-specific repositories can be an option for highlighting data management practices specific to a given discipline. If you do opt to use a domain-specific repository, be sure to select one that is most relevant to students. The Registry of Research Data Repositories is one option for discovering such repositories, but it's also good to look at recommendations from funding agencies or data and code availability statements from relevant journals in the field. These latter two options can also be good to include as talking points for introducing data sharing as an expectation of research to students and what it will look like with the funders who they'll be applying to, as well as to the journals where they'll be submitting their research. Once you've introduced the repository to students, give them time for independent exploration in which they search for a data set relevant to their research or interests, and which they could see themselves reusing in some capacity. Guiding questions that you can give to students here include simple things like, can you open and run all of the files on your computer? Can you understand what distinguishes multiple files from one another, or is the naming system confusing? Can you interpret all variable names, and do you know what units of measurement are being used on them? And do you know where to find that information? And most importantly, the overarching question here, how easy would it be to reproduce the original researcher's analysis or otherwise interpret it? And what qualities of the data set make it easier or harder for you to do so? The intention of this last question is to help break the concept of data management down for students from one overall theme into discrete practices that they can look for in a data set and incorporate into their own research practices. When I first delivered this lesson, students identified a number of common data management issues that would impede reuse, some of which I'll give examples of here. These examples all come from data sets shared via data repositories, and I'm highlighting them here not to shame any researchers, but simply to emphasize that there's plenty of material for students to pick up on if you go digging in a data repository. First, students can find a wide variety of file naming conventions and folder structures. Some of these will be clear, some of them will be confusing, and some of them may be entirely non-existent. Additionally, students can note the diversity of locations where they can find the documentation necessary to interpret the data. It might be in a README file or data dictionary, on an Excel spreadsheet with the data tables themselves, or even separately in the methodology section of a linked publication. They will also frequently encounter unexplained variable names or abbreviations for unexplained variable names or abbreviations or variables without units attached to them, even in the supporting documentation. And finally, they may find self-effacing comments in the code, the result of researchers documenting their own frustration with data analysis in real time, and which are now immortalized in these data repositories. The rest of the lesson can be devoted to discussion of common data management best practices. Depending on the discipline, the bulk of this time can be spent on data documentation, such as README files, data dictionaries, file naming conventions, and effective code commenting. When possible, reference the direct problems that students themselves have identified in their data sets and explain how these techniques you're introducing could be direct responses to those problems. Doing so is a means of demonstrating the real-world importance of data management practices and ties the information to specific examples students have just spent their own time investigating. This can also be an opportunity to discuss or introduce more open-ended concepts rather than discrete practices, such as dataset metadata or citation practices, and the way that a repository might facilitate or impede these. The lesson I've outlined here provides a fair amount of freedom for students to search for and assess whatever data set they find personally worthwhile on the theory that it will lead to increased engagement. But there are some variations that can be used for students who may need more structure, or if there are certain concepts you want to guarantee will surface. One option is to provide students with a list of pre-selected articles with data shared in a repository, or even a list of the data sets themselves, which limits the search space for students significantly and makes the task at hand more manageable. If there are certain concepts you need to highlight which don't lend themselves well to what's found in a final data set, another option is to have students review other data materials that get produced during the research process, such as a lab notebook. In an article for the Journal of Microbiology and Biology Education, Hills and Light lay out one such assignment in which undergraduate students identify and respond to errors in the lab notebooks of a fictional student. Their lesson plan similarly focuses on having students approach a lab notebook from the perspective of rerunning an experiment and data analysis. In their assessment of student learning, they found that students were more likely to identify poor data management practices when provided with the structure of a rubric for evaluating those specific practices. So again, more evidence of the importance of breaking data management down into discrete practices. I first delivered this lesson during the spring 2024 semester in a graduate course on scientific publishing and found it to be successful. This course was in many ways an ideal fit for this type of content. The professor was highly supportive of data management education and eager to invite me in for a guest lesson. And the subject of the course meant that students were already thinking critically about scholarly communication and research dissemination issues. However, I've since pitched this session and found interest among professors for graduate level courses in biology, biostatistics, and rehabilitative sciences, so I do consider it to be a fit for a wide variety of disciplines. While I had originally planned to have delivered more versions of this lesson early in the semester, and therefore have more assessment information to share here, unfortunately, personal circumstances have meant that I've needed to postpone those lessons for later in the semester. As for delivering the lesson itself, students surface every data management practice I have planned to discuss, giving me a host of examples to draw on. While I gave them multiple generalist repositories to choose from, the majority chose datasets from Dryad and looked at datasets formatted as Excel spreadsheets, which led to a robust discussion on data management in Excel and a wider conversation on which software tools are more or less suited for reproducible workflows and data analysis. This was a direction I hadn't planned for the lesson to go in, but it was nevertheless very much on theme and a fruitful discussion. In sharing their feedback on the lesson, one student explicitly noted that starting with the dataset exploration and assessment activity made the session more understandable and emphasized the importance of data management, which was gratifying for me to hear. So in closing, while I plan to adapt this lesson further as I gain additional feedback from students, I'll continue to work within the core theme of flipping the data lifecycle and starting with dataset discovery to provide grounding that ties semi-abstract concepts in data management to the very real challenges and responsibilities that students experience as they grow in their careers as researchers. The overall structure of the lesson is intended as a conversation with students in which they are responsible for identifying problems in data management, and the instructor offers actionable solutions to what they've identified. Finally, as I pitch this lesson for different courses, I'm mindful of the time pressures that many instructors feel, and so work to communicate the impact of this lesson in a relatively short time frame. In addressing this challenge more holistically in the future, I intend to try working with departments as a whole in order to determine the courses where data management instruction can fit in best into the overall curriculum, and thus avoid the problem where data management is left out entirely because every instructor believes that it would be better covered in a different course. Thank you very much for your time, and I'm open to any questions.
Lots of positive responses in the chat, and I think there were some questions. Here's one. Do you get the sense that your students successfully make the leap to building their own documentation?
That's a good question, and one that I think I can't answer with confidence without more evaluation here. One direction, once I sort of delivered this lesson a few more times and gotten more feedback on the effectiveness of the lesson itself, would be to actually be able to partner with an instructor to resurvey the students at the end of the course and ask what they've retained from that lesson, or any practices that they may have started implementing in doing their own research data management. So for example, asking about do they have they started using a README file for any of their practices? Have they started implementing a file naming convention? Are they sticking to it? How's that going? So getting a sense of being able to make more of a causal link to the lesson itself. At this stage, I'm still I do think subjectively that students do seem to be sticking with that, and that's something that I've heard in the feedback immediately after the lesson itself. But obviously, that's a very different question than what is sticking with students long term. But that is the overall aim here, and something that I plan on assessing more in the future.
Another question was saying they love this concept. Our data management workshops have varied attendance from undergrad staff, grad students, postdocs, and faculty. Do you think this approach would work equally well for these audiences besides grad students?
Yeah, I think it definitely can. I sort of experienced something similarly at with our data management workshops. We do ones where we hold them at the library or over Zoom, and they have open attendance. And those are moderately well attended, particularly when we do them over Zoom, sort of as a lunch and learn session. But we've gotten a lot more attendance at events where we have explicitly partnered with another organization, whether that's our Center for Clinical and Translational Science, or actually including that instruction in a class. And so that's what I would recommend in terms of instruction in those spaces. Another area where we see a lot of interest is around policy explanations, particularly for the NIH data management and sharing policy. So I find that a lot of what researchers are looking for there is very nuts and bolts information on how you actually write the plan. But I think of conversations about repositories and more discrete data management practices as kind of like stuffing the vegetables into the brownie that they're coming for. You know, using that as an opportunity to talk about some of these best practices that maybe aren't going to come up in a 2-page NIH DMSP, but that are nevertheless very much in the spirit of that policy and what the NIH is looking for there. And yeah, those are my general thoughts when it comes to looking not just at audiences for graduate students. Here, you know, it's designed to be able to fit into coursework. But I would say that if you have a model that, if you have relationships on campus that work well for attendance, then I think I could see it working well for other audiences as well.
That leads well into this next question about how much time does this take, and do you believe you're given enough time for it?
Yeah, in terms of prep, I found it actually took less time than the other data management instruction I was doing, because it allows for so much more interaction and engagement with students. So I make sure to give a fair amount of time for that, usually around 10 minutes or so, before we start leaping into conversation. And then from there, I think it depends a little bit on how you know, chatty a group of students you are. When I delivered this lesson the first time, it was a very engaged group. And so that sort of led to a lot of questions that they had that segued very nicely into the more lecture portion. The way I would recommend modulating it when it comes to time would be looking at which data management practices you want to highlight. So the big ones that I think come up in these data sets are things like documentation issues. So looking at README files and data dictionaries, data file organization, so file naming conventions, folder structure, and then code commenting as well. So those are the practices that I've chosen to focus on here. But other good ones, you know, looking at backup policies, the 3-2-1 rule, thinking about issues specific to data management on research teams as opposed to individuals. Those are ways, those are areas I would focus on more if I got more than, say, an hour or so with students.
Thank you. Any other questions? Okay, well, we just have a few minutes left and I would like to ask everyone to stick around. I'm just going to go over a few final logistics before we close. But while I'm pulling up the slides, love to give another round of applause for our speakers today. Okay. Oh goodness. That one. Okay. Okay. I don't think that's okay. All right. And I don't have the chat though. Okay. So thank you everyone. Thank you to all of our presenters, to all of our workshop presenters as well, posters, short talks. We really appreciate all the work that you put into this. We could not do it without you. I always like seeing at the end of a conference or at the beginning kind of a little bit of the scope of who attended. We had over 140 attendees this year, pretty similar to last year, I think slight uptick. And they came from over 90 different institutions, both within the Southeast US, but also beyond. And because this is a virtual conference, it really doesn't matter where you're from, you're welcome to come. We had 12 short talks, we had 8 fantastic posters. We've got 2 workshops, one more this afternoon. I think that social hour today, or on the first night, went really well, and another keynote this year. So that's kind of a little snapshot. Just as a reminder, if for you presenters, please make sure if you haven't already to, if you're willing to share your presentation materials with us, we'll put those in Open Science Framework. And also, this is the audience that's probably interested and also attending RDAP. Their call for proposal is open now and closes in about a month. So there's still plenty of time to get something together for that. And the focus this upcoming year is on resiliency, which I think is really interesting. For presenters or attendees, there's a couple potential publishing opportunities if you want to write something about SEDLS, either about your presentation or just reflections. Always looking for features in the RDAP newsletter, so you can reach out to someone on the publishing committee there if you want to write again about what you presented here, or also just reflections about the conference. And then IASIS puts out a quarterly publication, and they're always welcoming submissions based off of presentations, and Research Data Queue as well, which is run through out of ACRL. They have a call for proposals for editorials once or twice a year. I think the next one's coming up soon. And so those are just some options for you going forward. And last remarks here, there is an attendee certificate, so if you need proof of attendance, go ahead and use that. We sent out a presenter certificate for all of our presenters as well. The recordings will be up on YouTube with the once we get them all merged with the captions and things like that, and the presentation slides and posters will be up. And I want to make sure that we share out these feedback surveys for 2024, and then also the planning interest survey. It is really important for us to get feedback. We're run as just a completely volunteer group. We know we can make this better every year, and we do try to make it better. But we really need your input on how to do that. And then also, because we are a volunteer run group, we're always looking for more members.